For this section, we're going to talk about triangles, specifically classifying triangles by their sides and by their angles. Now, the sides have three different vocabulary words that you need to take note of. The first is scalene. That means that all three sides have a different length, or in other words, there are no congruent sides. The second vocab word for sides is isosceles. From chapter 8, you recall that these markings right here mean that these two sides have the same length, or they're congruent. An isosceles triangle has two congruent sides. And our third word is equilateral, and you can see those markings again, but now on all three sides. Equilateral means that all sides are congruent in the triangle. Let's go to our angles now. The first definition for angles is acute. Acute means less than 90 degrees. An acute triangle has all three angles that measure less than 90 degrees. This one, we can see the marking right here for a right angle or a 90-degree angle. Any triangle that contains a right angle is called a right triangle. That's our second vocab word for angles. Third is obtuse. The word obtuse means that it is greater than 90 degrees. And we can see that this angle right here is larger than 90 degrees. The other two are acute angles, but if we have one angle that is obtuse, the triangle as a whole is known as obtuse. And last, we have equiangular. That means all angles are congruent. We've got 1, 2, 3 angles here, and they all have the same measure. Equiangular and equilateral are actually interchangeable. If all three angles are the same length, then all three sides will also be the same length. Or if all three angles are the same measure, all three sides will be the same length. Now let's take a look at a few different triangles over here. We're going to classify these triangles. Now this first one right here, we have three sides and none of them are congruent to each other. So this is scalene if we're talking about sides. If we're talking about angles, you can see that all three of these angles are smaller than 90 degrees. So this is an acute triangle. When we classify the triangle, it might have more than one classification, and you might be required to write down all of them. So this one would be scalene and acute. Okay, right here we can see that all three angles are the same measure because of that arc on all three angles. So this is equiangular. And if all three angles are the same length, then all three sides are also the same length. So this is also an equilateral triangle. All right, and on this one we can see the right angle. So by angles, this is a right triangle. And we can see that two of these sides are congruent to each other, so this is also isosceles. So make sure you take a look and get all of the categories if they have multiple. Let's take a look at these two triangles on this diagram. Our job again is to classify them. And so we're going to take a look at some of the measurements. Now you'll notice this triangle has a vertical and a horizontal line. That means that this angle right here is a 90-degree angle. So this is a right triangle. Let's take a look at the lengths of the sides. We notice that this one is 1, 2, 3, 4, and this one is 1, 2, 3, 4. Since both of these have the same length, that this is also an isosceles triangle. This third side is longer than all the others, so it is not an equilateral triangle. Let's take a look at this one. Now clearly these three sides are not the same length. We could check that by going down and over and creating a triangle for each of these. So it's 1, 2, 3, 4, 5, 6 down and 1, 2 over. And this one clearly has a different measure. It's 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5 down. So these are not the same length, and that one is also much shorter than the other two. This might be a right triangle though, so let's take a look and see if these two sides are perpendicular to each other. Now we need to review perpendicular slopes of lines. If two lines are perpendicular to each other, their slopes will be negative reciprocals. Negative reciprocals of each other. For example, if one of them had a slope of 2/5 The other one would have a slope of negative 5/2. So the negative part means that one is positive while the other is negative, and reciprocal means you're going to flip the fraction over. So the numerator and denominator switch places. So let's find the slope for these two lines. This one goes down and right. It goes down 1, 2, 3, 4, 5, 6. So that's a negative 6, and right 1, 2, so positive 2. Rise over run would make it negative 6 over 2. I'll simplify that in a second. This one goes right 1, 2, 3, and up 1. Those are both positive. So right 3 and up 1. If we do the slope, that would be rise over run, which is 1/3. Now these don't look like they're negative reciprocals. We must simplify this. 2 goes into both 6 and 2. 2 goes into 6 3 times, and 2 goes into 2 once. So that would be negative 3 over 1, and this is positive 1 over 3. So we can see that one is positive, the other is negative. So it's a negative. And the numerator and denominator have switched locations, so we have a reciprocal. That means that these two lines are perpendicular to each other. So this is a right triangle. It is scalene because none of the sides are the same length as each other. And we're finished.